Hello, this is Mr. Stansbury. I'm going to take you through the 6L notes on exponential equations. At the end of this, you should be able to say that you can solve equations where the variable is part of the exponent. Okay, so there's a little formula here. It says if a to the x equals a to the k, then x has to equal k. So basically, if we can get the bases to be the same, then these exponents have to then also equal the same if they're equal. All right, so let's take a look at an example. Example 42 from page 198. I'm going to show you two different ways to do this, one by hand and one by using logarithms and your calculator. Okay, so solve for x. We got 2 to the x equals 16. Now again, if we can get these two numbers here to be the same, then we're in business. And of course, this happens to work out that 16 is the same thing as 2 to the 4th. So if we have 2 to the x equals 2 to the 4th, if these bases are the same, then that means these exponents also have to be the same. So then x has to equal 4. Okay. Same idea over here. We want to look at the base numbers. And again, you don't have to look at this base number as 1 over 27. Just look at the 27 and say, hey, wait, 27 is an actual power of 3. So this is 3 to the x plus 2. And then 27 is actually 1 over 27 is 1 over 3 cubed. Okay. Now, again, these bases aren't the same because this is 1 over 3 cubed and this is 3. So what we have to do is we have to move this 3 cubed up here on the top, so then that base number is up on top. So we just rewrite it as 3 to the x plus 2 equals, and then this 3 cubed, again, to move this up to the top, the 3 stays the same, but now the exponent switches the sign. So since it's positive on the bottom, it's now going to be negative 3 on the top. Okay, so now we know that these, since the bases are the same, now we know that x plus 2 has to equal negative 3. So subtract 2, and we get that x equals negative 5. Okay? All right, now we're going to do the same thing here with the graphing calculator. Sorry, with the scientific calculator. Okay, so we've got this here, and what we're going to do is we're going to actually rewrite these things here as we're going to use logarithms to figure this out. Okay, so basically a logarithm means that you can figure out what if your variable is up in the exponent, we can use logarithms to solve it. Okay, so we're just going to do this. We take the log of both sides, so log of 2 to the x equals log 16. Okay, once you've taken the logarithm, this x out here, this power up here, can now be moved out to front, and now you're multiplying it. So it's really just x times log 2 equals log 16. Okay, so now we want to get x by itself, so we divide both sides by log 2. Okay, and then we're going to end up getting that x equals log 16 divided by log 2. Okay, so again, that's where our scientific calculator is going to come in handy. What we're going to do is we're going to hit the log button, and we're going to do log of 16 first. And I find that the easiest way to do this is to just do log 16, hit equals, and then now we want to divide that by log 2. So now we're going to hit divide by log 2, and we get that x equals 4, just like we had before. Okay. Now, we can also do this same process with this problem over here. So just do log both sides. Log 3 to the x plus 2 equals log 1 over 27. Okay? So now this x plus 2 can move out front. So we got x plus 2 times the log of 3 equals log of 1 over 27. Okay, now we want to get the x plus 2 by itself, so we divide both sides by log 3. And then what we get over here is going to be x plus 2 is going to equal log of 1 over 27 divided by log 3. Okay, so let's pull our calculator back up again and try that one out. So we'll do log of 1 divided by 27. I'm going to close my parentheses to make sure that it takes the log of 1/27th. And that gives us negative 1.4, blah, 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 blah. And we're going to divide that answer by the log of 3. Okay, and we put enter, and that gives us that x plus 2 equals negative 3. So now to figure out what x is, we just subtract 2 from both sides, and we get that x equals negative 5. Just like the same answer as we got doing it by hand. All right. Okay, we'll try a couple more examples here just to make sure that we've got this down, and away we go. All right, so here's a couple more. Solve for x. Again, you can do these by hand or with your scientific calculator using logarithms. I'm going to do these with the scientific calculator using logarithms because that's going to help us out a bit later on in the course too. So let's try this out. Log 4 to the x equals not x but 8, right? X comes out front, so we get x log 4 equals 8. Oh, not 8, but let me back up here because this is supposed to be log of 8. Sorry. So now that x comes out front, so we got x log 4 equals log 8, and we want to divide both sides by log 4. Okay, so we get x is going to equal whatever log 8 divided by log 4 is. All right, so let's pull our calculator up and try that out. So log 8 equals divide by log 4, and we get x equals 1.5. Okay, and then you can always double check to make sure that this works. 4 to the 1.5 power should equal 8. So let's try it. 4 to the, let's see, there's my exponent. 4 to the 1.5 equals 8. So then we know we have this right. Okay, let's try this one last one, and then we'll be all done. So same thing here. Log both sides. So log 9 to the x minus 2 should equal log of 1/3. This x minus 2 comes out front, so we got x minus 2 times log 9 equals log of 1/3. Okay, divide both sides by log 9, and we get that x minus 2 should equal log of 1/3 divided by log 9. All right, and let's put that in our calculator and see what we get. Okay, so we got log of 1/3 equals, divide that answer by log of 9, and we get negative 0.5. So we get x minus 2 should equal negative 0.5. So we add 2 to both sides, and we get that x equals 1.5. Okay, and then again, we can double check to make sure that that works by just plugging our answer back in, right? So 9 to the, and we can even just write 1.5 minus 2. All right, oops, syntax error, because let's see, I don't think I'm going to need that parentheses there. And we get 0.3333, which is 1/3. All right? Okay, so that's the 6L. Be sure to ask if you have any questions at all. All right? Thanks.